In this video, I'll show you how to find the domain and range of functions. This is part 4. In question 1, they ask, find the domain and range of y is equal to the square root of x minus 1. We have a radical here, and we know that the radicand, this part, can't be anything less than 0. Otherwise, you end up with imaginary numbers. So this part needs to be greater or equal to 0. X minus 1 is greater or equal to 0. We'll solve for x, and if we do that, we should end up with x needs to be greater or equal to 1. That is our only restriction, therefore that is our domain. So let's write that down in a formal way. The domain is all real x numbers such that x is greater or equal to 1. To find our range, we have to analyze what happens at x is equal to 1 and then analyze a number that is far greater than 1. So let's see what happens at x is equal to 1. That should give us an idea of the potential outputs. Y is equal to the square root of 1 minus 1. That's 0. So we know at 1, y will be 0. Let's try an x value of, let's say, 1,000. 1,000 minus 1 is 999. And if we find the square root of that, we end up with a y value greater than 0. In fact, any x value that we put greater than 1,000 will result into an output that's even larger. Therefore, we can say the range consists of all y values from 0 to infinity. And we write that down like this, where range consists of all y values that are real such that y is greater or equal to 0. In question 2, we're asked to find the domain and range of y is equal to 5 over x plus 2 and x minus 4, both in brackets. And when it comes to quotients, the denominator can never equal to 0. Now, what will make this equal to 0? We have to set this bracket not equal to 0 and set this bracket not equal to 0 and solve for x. So let's start with the first bracket. X plus 2 cannot equal to 0. If we take this 2 to the other side, we end up with x cannot equal to negative 2. Similarly, x minus 4 cannot equal to 0, and if we solve for x, we end up with simply 4. And that will dictate our domain. Our domain consists of all real x values where x is not equal to negative 2 and not equal to 4. So let's write that down. The domain are all real x values such that x cannot equal to negative 2 and it cannot equal to positive 4. Now we need to find the range, and this part gets tricky. Let's take a look at where these numbers lie in a number line. So this is 0, this right here is negative 2, and this right here is positive 4. And we're going to put asymptotes where there are no y outputs. So at negative 2 and 4. To find our range, we need to pick x values and evaluate them in the equation where x is between negative 2 and 4, greater than 4, and less than negative 2. If we apply a number that is very negative into our equation, let's say we applied negative 1,000. So x is equal to negative 1,000. Here's what happens. Y is equal to 5 over a very negative number times a very negative number. That gives us a positive number that is quite large. So 5 over a very large positive number will result in a y that is close to 0 but never quite reaches 0. So as x gets smaller and smaller and smaller, y gets closer and closer to 0. So we should end up with a graph that looks something like this from the left side. And if we put a number that is very close to negative 2 from the left side, so x is equal to, let's say, negative 2.0001. Let's use our calculator to demonstrate this. 5 divided by negative 2.0001 plus 2, bracket, negative 2.0001 minus 4 gives us a fairly large y value. And as shown, y gets larger as we get closer to negative 2. And if you pick numbers that are very positive, you'll get the same effect on the right side, except that y will start off very large and then it will make its way down to 0, but never quite reach 0. Here's what I mean. What about in between -2 and 4? The best thing to do is to start off with the midpoint of these two numbers. So we take the average, and that should give us a good starting point. So -2 plus 4 divided by 2. That's like saying 2 over 2, which is equal to 1. So let's try what happens at x is equal to 1. At x is equal to 1, we'll use your calculator, and we'll replace this number by 1, and we'll replace this number by 1 as well. We end up with -5 over 9. So at x is equal to 1, we have -5 over 9, which is equal to approximately -0.555 repeating. And we can say that's somewhere right here. Let's find out what happens just to the right of -2 and just to the left of 4. So let's pretend that we had a number like 3.999 and 3.999. We end up with a fairly large negative number down here. So the y output would end up getting smaller and smaller as it approaches +4. And the same thing goes with if we put a number close to -2. Let me demonstrate. -1.999, we would get a very small y value. This means that our range includes all real y values such that y is less than or equal to -5 over 9 and y is greater than 0. And so there you have it. 2 more examples on how to find the domain and range of functions.